Well, thank you everyone who's responded to this poll. Again, we love seeing where everyone's from. And thank you for joining this webinar. This is part of our Robots to the Rescue series as part of our design challenge. So again, we thank you for joining this and coming to attend this session. Tonight, it'll be myself, Mackenzie Brunell, an academic application engineer at PTC, joined by one of my colleagues, Mark Kelly, who's going to be answering some of your questions in the chat as you post those throughout the night. And then we're also going to have some great external guests, John and Chris, who will be talking about the part library that they've curated over the years. So for tonight's agenda, first we're going to give a quick overview about the competition. Then we'll go into using that FTC Parts Library, and then we'll have some time for Q&A. So again, feel free to post any questions in the chat or in the question box throughout the night, and we'll be getting to those as we can. And so if you haven't heard about this design challenge, the challenge is to design a robot that solves a current world problem. And you can sign up for that on our website. You can also find the rules and guidelines online. You can stay up to date with those rules as we make any clarifications. If you have any questions about those, if you've been looking, definitely feel free to email us to ask. This is our first time putting on this challenge, so we're absolutely happy to give any of those clarifications and talk through anything that you may be confused about. And then just a few clarifications based on some of the questions that we've gotten in so far. An alliance can be any number of FRC or FTC teams joined together, but each team will submit your own robot and then be scored individually. And if you are looking for teams to join with, I highly suggest there have been some teams that have posted Google Forms to go through and actually find a team that's still looking for an alliance member. That was sent out in our most recent email, and then it also can be found on Chief Delphi. And then for those robot requirements, there are some size constraints. So I definitely recommend looking at our website to see those. And then for FTC, the only hard and fast rule is looking at the Skystone Manual, Section 732 allowed materials. And then we do suggest using some of those standard components. If you look at the judging rubric, you can see that that's one of the scoring criteria. It's not a requirement, but again, it is if you want to get those full points. And then any other rules about the robot use and intent don't apply. So if you're wondering something about the robot holding liquids, or if there's something that maybe the robot's going to be sharp and could damage another robot in play, that won't apply here, since the robots will actually be on a playing field, and the safety concerns that would be on a physical robot don't matter as much in this design competition. And then we do have several other resources in addition to these webinars for you. I highly recommend looking at the Onshape Learning Center. If you're new to CAD, there's a great learning pathway, or if you're familiar with CAD, there's a separate pathway that I also recommend. And then for the parts libraries, Team 2901 is going to go into their part library tonight, and for access to that, you can email us at first@ptc.com. And just a reminder of some of the important dates. On May 1st, we're going to be sending you that submission form, and then you can submit by the deadline on May 15th. And then throughout that, we'll be having several webinars, and we've already had some of those webinars too. And so if you missed some of those first couple of webinars we had, they're all on our PTC YouTube, so you can look at those recordings there. We talked about the introduction to Onshape, the FRC kit of parts, migrating your team from a different CAD system, and then tonight, obviously, we're talking about the FTC kit of parts, and then moving forward, we'll talk about collaborating and versioning. We'll have a panel next week to go through some teams that are experienced can give some suggestions and just answer some of your questions about using Onshape. And then we'll have a session about preparing your submission. And finally, we'll have an office hour where you can ask any last-minute questions about using Onshape, or if you're just wondering something about submitting and those requirements. And again, if you have any questions, you can definitely be using that chat, or you can email us at first@ptc.com. And then I just wanted to ask, which team are you on? So just wondering what teams are here represented. If you can respond at this pollev.com URL that you were on before, if you did that location, but we just like to see, again, who's here with us tonight. We've got a few teams with quite a few people from Cyber Night. And if you do have team members that weren't able to join us, again, that this webinar is being recorded, so you can definitely be sending it to other team members or to other teams in your area that you want to join an alliance with. Maybe they haven't used Onshape before. You can definitely be sending them all of these recordings and sharing them with them. That's for Metro and Cyber Nights. Just another moment, and then we'll switch it over to John to go into that FTC Parts Library. Awesome. All right, I'm gonna hand it over to John now.
All right, thank you, Mackenzie. Hi, everybody. I'm John Toebes. I'm the head coach for FTC Team 2901 Purple Gears, and joining me is Chris Paratovich. He'll get his webcam on in a second, but we'll be going back and forth talking to you about the library. Let's talk a little bit about what is in the library. Basically, we've been using Onshape for a year and a half, 2 years now, and we needed to have components from the common FTC vendors. You know, everybody uses Pitsco and ServoCity and GoBuilder and Rev Robotics, but the challenge is every team that goes in ends up copying the parts into their own library. I mean, they're used to this from doing it with Creo and other programs. We have to download everything, but the challenge is, oh, I need another part. Oh, I need another part. And eventually you start having this big mess of parts. So we decided we wanted to provide some organization. And so with this, we have components from a lot of the vendors. So Pitsco, we worked with them. They gave us a list and all of their models. They have about 250 components. It's about 90% populated. There's a few of their max parts that we haven't put in there, but pretty much the standard Pitsco Tetrix kit of parts, all of them are in there. ServoCity. Anybody that's been there, they have over 5,000 components on their website. We've populated about 80% of them, and it's probably worth noting that only 20% of the models on the ServoCity website actually had models. So we've created models for many of the parts that they don't have models for on their website. GoBuilder has about 700. About 80% of them are on here. Jeff Reed from one of the local teams was very heavily involved in doing that. Rev Robotics, there's about 300 parts. They're populated, not all standardized. We'll talk about what we mean by the standardized, but the parts are in there. And then Andy Mark has 1,200 components. We've just gotten started there, putting the components in, except for the motors. The motors are obviously in there. We use them. McMaster-Carr, people go there all the time. There's 500,000 parts. We only import those as needed. And by the way, there is a VEX folder that was added because someone submitted a part from VEX, so we just went ahead and added it into the library. And when you go to the library, if you go to Onshape, you will find there's a document in the root of each of the folders called the FTC Parts Library. And it gives you a good introduction to all the things you need to know about the library. How do you get access? Some information about finding parts. We've got some nice guides in here that show you the things. And talks a little bit, we'll go about the standards a little bit later on. But let's talk about the basic features that are in this library. First of all, we spent time to organize it just like the vendor website. In other words, when you go to ServoCity, you navigate down, you start with motion components, then you go underneath that. Well, we made that same organization reflected in folders with the library that we built. All the components have the SKUs, the vendor numbers, has a link to the website and full information. So when you generate a BOM, bill of materials for your robot or your design, you actually have all the part information. So you could order them from that. We also paid attention to parts and assemblies as appropriate. So we talk about the various things that the vendors offer. Sometimes it's a simple part like a screw or a bushing. Sometimes it's more complex in assembly, such as motors and bearings. And so for those assemblies, we put proper mates for all of the moving parts. So the motors and the bearings, you'll see the bearings have an inner and outer race, and it has a revolute relationship between the two. So we just drop the bearing into your part. You can mate to the inside, mate to the outside, and your robot will work correctly. We've added this concept of configurable components. How many times have you gone, someone says, oh, give me a channel, U channel for it. Well, how long a U channel? Well, I don't know. Let's try the 15-inch. Oh, maybe the 18-inch. Oh, we might change it. We've made it so that you can make them configurable. The same thing with gears and sprockets and various bars. The things that you might have, you're not sure what the size is, you want to change your mind, you can do that without having to re-import the parts. Also works for motors. So the various Go Build a motors, you can actually choose what speed you want. It'll automatically adjust the size of the motor. We have sample kits. We put a number of them. We'll talk about, I'll show you an example. And what we've done is we've got a proper bill of materials for everything. So all of the assemblies and the parts give the information that you'll need in order to find it. And here's what's really important is we've assigned materials to all the parts that have been imported so you can use them for weight measurements and standardize the colors. By default, when you import something in Onshape, you sort of get random colors. And you'll see that if you're going and pulling parts from the public library in Onshape, that your robot ends up looking like a clown vehicle of sorts. And for many of the motors, we put what we call wire placement stubs. Wiring is a very advanced topic with Onshape, but at least we tried to make it so that if you want to do wiring, you've got something to start from. So what we wanted to do is just to give you an idea of using this library. So what we're going to do is Chris and I are going to show you a little bit of power of Onshape. We're going to simultaneously work together and assemble a demo robot. Now I'm going to pull up a demo robot. Let's see if we got that. Where are we at?
Yep, we would like to go to just demo robot, but not demo robot assembly.
Okay, in the Coach's Sandbox. So we have a demo robot.
Mm-hmm.
And what's going to happen is Chris and I are both going to be working at the same time. So let me open up a new tab.
Yep, we're going to be using the follow feature on Onshape so that hopefully we can see what both of us are doing at the same time.
So for people who have not experienced the power of Onshape, Onshape has got some really nice capabilities to be able to collaborate as a team. Let me get this. It's not maximized.
You could probably see the view that I'm rotating in the screen, kind of updating on the upper right, I'm sure, in the shared screen view.
And so what we're going to do is we're going to try and see how quickly we can assemble a little bit of a robot. All right, so let's just go. What I'm going to do is I'm going to insert some parts from Servo City. I'm going to need some structural components, and I'm going to need a pattern mount. And the side tap pattern mount is a really good one. And next, I'm also going to need some channels, the standard channels. I'm going to need a 9-inch channel, and I'm going to need a 12-inch channel.
Yep, since we aim to have 4 motors in this assembly, we're trying to make it so that all of the motors, or the motor itself, plus like the mount, lives in one sub-assembly so that we can easily duplicate this motor mounted assembly throughout the document.
And so what I'm going to do is while Chris is working on his part, I'm going to go ahead and start assembling sort of our basic chassis. So do that, standard mate there, mate it to that, and put that on the other side. People who have worked with the Servo City Actobotics know that this is a really good part to put on the end so you can match something. And I'm going to mate that to our channel. Solve is a very nice feature when you're putting a part in there. If you notice, what I've done is I mated it, I solved it, and now I've got that part in there. What I'm going to do is I'll go back to my main robot, and now that I've got half of it together, take advantage of the assembly, and I am going to mate this other half to the part that I already did.
Yep. And here's a case where I have to use an offset because I'm attempting to set the where I'd like this hub to clamp onto the motor. I think it's 0.3 or so. Yeah, that looks good.
And so now I'm going to make, he's already built this motor for it, the motor that's holding the wheel. You can see as he assembles it, it shows up on mine.
Yep, and now I'll be putting in the screws that attach the motor to the hub. Oops, let me get out of that context. I clicked the wrong surface. And standard content's pretty nice. Just it's a feature built into Onshape so that you can insert standard screws and washers and bolts. And we use it pretty extensively. You just kind of highlight the surfaces you want, insert the component, and there it is. So now this motor assembly is done. So I'm actually going to go back to John's document and start putting in fasteners. So we're both going to be working in the actual same assembly document.
And now we've got the wheels in. You can see he's working on that. He's putting in the screws. And if we go back to the main robot document, we can see that we have most of it assembled. One thing that we need is it's an FTC robot, so we need to have our rev hub. So under FTC, electronics, control system, the rev control hub, and we want the assembly. And we've got the control hub in, and
last set of screws.
Right, and I don't even have to wait for Chris as he's working. As his stuff gets done, it automatically shows up.
All right, now I'm going to go over here and load and see what John put together here. And hey, yeah, that's a robot.
And so now what we've done is we put together a robot in about 4 minutes. We've practiced a little bit, but this is something that might be an interesting challenge for you to put to your team is pick a design and see how quickly everybody can replicate that design, particularly working together. And that's the nice capability that you get out of Onshape. So with that in mind, what we're going to do is let's give you an idea of what is in the library. And I'd like to show you some of the standard information that we have. We take any one of these parts. So for example, we've got this, this is a clamping hub. One of the things that happens in Onshape is that the text for the name sort of just gets chopped off. So we spend some time thinking about that when you're going through these parts. Notice you have the pictures so you can see what you're going to go insert. But on the right-hand side, we have the document description, which includes the name of the part number, and the URL to go to on the website in order for you to be able to get that part. With that, I'm going to let Chris take over.
All right, you change presenter. Okay, I'm going to show screen. All right, here we go. Can everyone see the screen? Am I sharing correctly?
Yes.
Okay, let me go present here. Okay, so we're going to go through some general principles that we like to put together in this library. I think number one was basically you want to be able to put together this robot as efficiently as possible, and that means one, being able to find the parts. So it's organized in the same way as the website, so you could also search by the part name, the part number, and basically make it so that the distance between you and getting the part that you want in the assembly is as fast as possible. One principle that we have is that all parts in the assembly which can move are assemblies. A good example of this is a bearing, which I have pulled up here. So one thing that we did is anything that can move, like the inner versus outer race of a bearing. I don't know if you can see this make connector moving, but we tried to make it so that we have named connections where you would, ideally connect this, like put it in your robot model. So this flange is maybe you put in an active box bar, and then maybe this is possibly cylindrical made on a shaft. Okay, what do we have? So now we have configurable components when possible. I think John touched on this earlier. If you have something like a gear or a sprocket or something that wants to change size, say, oh, I need to change this out for a 32 tooth gear for a 48 tooth gear. Basically be able to right click it and change the number of teeth, have it update automatically, and have the correct part number and metadata.
And we'll show you an example of this later.
Yep. Screws and set screws combined into one part with possible. So an example of this is This really is one part. It always comes with the set screw. You know, it's there's a few reasons for this. One is just there's really no reason to have all these additional mate connectors and other part numbers hanging around. It also helps with like performance, because when it's moving in an assembly around, you don't have to solve all these additional constraints on the model. It's just one part. That's the only thing it can do. The set screw is always a part of this. Okay, parts are oriented as they appear on the vendor website. That's important for us. So if we're looking at a part on the website, we can go back to the model and say, yep, that's pretty much what I'm looking for. Parts of assembly do not appear in the BOM. What we mean by this is you may have something like a, let's take like a Never-S motor, for example. The motor assembly is comprised of a gearbox part number and a gear motor part number. However, if we were to expand this, it doesn't have any of the parts, like the shaft sticking out of the motor, any of the gears inside, you know, the back encoder, mostly because when you have a bill of materials, this is what you're going to order. We're not going to order like the individual shaft of a motor. So we make sure that whatever parts build up this assembly in our parts library, that none of those contain the information that would be duplicated with what should be captured in the assembly. Yep. And lastly, yeah, vendor information on assembly and parts, and not parts. We could just cover that. Okay, so finding vendor components. This is what one of the things we're trying to show in the demo that we had put together. So let's say I'm going to insert a part into this new assembly. Once you're added to this group, you can just go to FTC Robotics part users. You can navigate to it manually like you would on the website. You could search for some part number, like, what was it, 555168, one of the ones that we had earlier, or 168. But anyways, you could search for a part number, or you could search for like clamping hub, and that might pop up. So, yep, here we go. Here's all these different clamping hubs. So this is just one example of us really trying to, you know, streamline the process of just, you know, getting to the part you want. Yep, and then choose the part as assembly is appropriate and insert. What we mean by this. So some parts, we are just looking at that bearing, are intended to be used as an assembly and not a part. And so what we've done is that any of the assemblies in our parts library or the component library, wherever the imported parts are, we put this big red X in here, which is hidden in the assembly or not imported into the assembly. And this is basically just an easy way to say, hey, don't use the parts here, don't insert the inner race or outer race. We intend you to use this as the model for the bearing.
Yeah, the real key is if you inserted the parts, what happens is you move the part around, one piece will move without the other.
Yep. Okay, and don't search globally. This is what we were talking about earlier on the, so if I were to go back here and I were to go back to, what's the part number for this one? Or
58, let's see, why don't you look for
545385. So if
yep.
I go in here and I search everything in here, this is basically searching globally. So every folder in here is going to search, and the big one it's going to search here is public. So if I were to search 545385, it's going to pull up all kinds of different parts that are not the ones in the part library. And so you have all these different color ones that don't quite match it. Luckily, this is the one that we have in our parts library, which is showing up. Oh yeah, oh, here you go. Here's all the other ones that are kind of out there. So what we're saying is, instead of like basically searching in your top level directory, make sure to go into the FTC Robotics part users library before searching for that part. And let me just verify that it always pulls up the right one. So 545385. Yep, and there it is. This is the one that we have. And these are other ones that just caught the same thing because it's the name of the tab, the name of other parts. But yep, it isn't pulling anything else in the public repository. It's pulling the version that is intended to be used.
Yeah, all three of those are the same part, but we made sure that we named the tab, the part, and the document so that you will always find what you're looking for.
Sure. So whenever we use like an inserted motor, one of the examples that we actually had here, which is the never rest. So what do we have in our drive base here?
In the motor assembly. Go in the motor assembly.
Okay, yeah. So I'm actually going to open up this link document. Oh, here it goes. Oh, so one thing that we do is for motors specifically, we make it so that this is really the only rotating component, because this is the 1 degree of freedom that motors really offer you. And so in order to mate these, we recommend using 3 different mates. If we had something with like a set screw, one of them is going to be, you would really like this set screw to be parallel with the shaft, since when it's on there, the set screw tightens down, it's going to align itself the top of this parallel with the shaft. Another one is that you're going to set a cylindrical mate onto there. So basically, this is the one that's going to keep it concentric with the shaft. And then finally, you'll want to have a way to set the distance from the end of the shaft to the hub. And so this is one example where we have the 1 degree of freedom to give you to mate a hub to. And so this is like the preferred way to do that. Yep, and one thing, another common operation that you may do is you may find that you may need to modify an existing part in the library. An example is, maybe I want this big cutout in this Actibotics bar. And so there is a few different ways to do it. There's one way that is probably the correct way, and that's to use what's called a derived part. So you could copy a part from another document, like I could grab some other part, I could try, do a copy and paste into another document. But the issue with that is it's actually going to copy the workspace in Onshape, and it's going to allow you to modify whatever you want in there. And if you were to change the part number or other properties on it, it wouldn't be preserved, and it would be hard to order that part. Now, if I do this as a derived component, like I've done here, basically derived kind of looks like inserting a component into an assembly, except this is in a parts studio. And what this does is it makes it so that when you insert one of these parts, it now says, yes, this is the part that you had derived it from. It's going to have all the same vendor information that we had before, and no matter what I do from it, this will stay the same. And the other nice thing is that if this were to change, like let's say we found that there was an error in the modeling of this bar. If that were to change, we'd have a logo right here that says, would you like to update the derived component? And you'd say, sure. And then you'd have the latest and greatest up-to-date model, so that you don't have to go back and re-import something or recopy something and make changes that way. All right, I think I'm going to pass it back over to John, who is going to take us through configurable components.
Yes. So as we talked about, one of the nice features we've done is made the components so that you can configure them. And give you an example of a configurable component. Oh, okay. We're going to go and insert 2 of the obvious things that you want to configure. And I just happen to recently open, is going to be a Tetrix Max channel. And when you get a configurable component, well, you'll notice is because the name of the document says configurable. And if you look, when you insert it, you get a choice of the configuration. Do I want the 1-hole, the 5-hole, the 9-hole version? So I'll take the 9-hole version and put that in. And I'm also going to insert to me a motor and a yellow jacket motor. Notice this. See, it was on the Parts Studio. Do not use parts. The big red X really points that out. So you go to the assemblies, because the assembly gives me my choice of what ratio motor. So I'm going to take the 180, the 30 RPM, so the highest torque motor that they have. Insert that. And so now I've got these 2 parts, and I'm not going to bother mating them, but all right, well, oh, I really wanted a different size channel. So you just come up here and you say change configuration. And instead of being the 9-hole, I want the 25-hole, and it changes it without me having to do any updates to my model. And the same thing with the motor, change configuration. Oh, I need a motor that's got more torque, or actually I need a motor that's faster. That's too much. So we're just going to go the other end of the spectrum, and you can see it changes because the gearbox on the yellow jacket motors is different for the different torques. So that's one nice feature that we get out of this. Not all the parts are configurable. One of the ones that we want to make configurable that's not currently is the bearings. We'd like to be able to do that, but the geometry of them is different. We're looking at a way of making that happen. So
And one of the important parts, also the configuration, is not only are you changing the geometry, but along with changing that, the part number and description and all that will also change.
So we talked about the bill of materials. And with the bill of materials, when you've inserted all the parts into the robot, so this is our demo robot or that we've done, on the right-hand side of the screen, you get the BOM table. And by default, it gives you the flattened BOM. Well, that's not quite what we want. We look at that, that's not really what our robot is. You want to use the structured BOM. And you say we've got the drive base half, which got 2 of, and the control hub. So we can expand the drive base half, and that has the motor assembly. We can expand that. And now we can see all the parts that are in our robot, the part numbers, where we want to go and buy them, and the quantity. Also, remember when you have a sub, you have to multiply this quantity by that by 2, but that's an easy thing for you to do. The nice thing is this can be copied into a spreadsheet, and you can go and go to your ordering person and say, hey, we really need this for the robot. Now, suppose there's a lot of parts. As you saw from the original list, we haven't done all of them. There's an opportunity for people to continue adding vendor parts. And by the way, the vendors add them all the time. So sometimes someone comes up with a new part that you need and is not in the library. So the first thing you want to do, if you want to add parts to the library, is we do have, if you look in our parts library, there is a link. There are a couple of documents in here. One is our standards. We tell you what the standards are. We tell you the naming standards, the document properties, the color choices that we've made. And we have a link to the spreadsheets with the status of all the various parts. So for example, Servo City, all of the motors and actuators have been done. All the structural components have been done. You can see them in green. The motion components, there's a few that are still to be done. The team has been very aggressively working on making all of these configurable parts. Servo City has 5,500 components, so it does take a while. Pitsco was not kind enough, they gave us the whole list and we put them in. Go Builda. I would say we're about 80% of the way through with Go Builda. And the nice thing about it is we do have guides for how to edit it, step by step. So for example, if I'm going to edit just a simple part, go open the spreadsheet, copy the part, insert. We give you every single click in order to follow and set up the parts and make them meet the standards. This one's got 27 steps. We even tell you information for how to do a configurable part. So here's how to do a configurable part, and then how to create the first configured part and the multiple parts from it, because you want to have the configurable part and all the individual configured parts of when someone wants to enter them in. Once you've done that, follow the standards. There's a library location called Robot Parts Contributions. So if you've got a new one, put it in there. You can send email to robotics@cghsnc.org, but we actually look in that directory pretty regularly and we'll move them. Once you've successfully done 5 parts, if you want to keep going and you got more than you want to do, once 5 have passed through, then send email to robotics@cghsnc.org and we will add you to the list of admins who have permissions to edit the parts. Basically, if you see a problem, something that's gone wrong, something that we didn't think about right, send email, robotics@cghsnc.org. And if you want access to the parts library, just send email to first@ptc.com and they'll automatically add you to the library so it appears. And with that, we are open for questions. It looks like I'm not sure how the interface works. How do you switch from sketch mode to assembly mode? Very, very good question. So what happens is whenever you create a document, I'm just going to go ahead and create a new document from scratch. Create document. By default, a new document has a part studio and an assembly. So a part studio is for an individual, I want to say one part, that's kind of, but it's for a non-moving piece of materials, generally things that are all of one size. So for example, we'll just do a quick sketch and create ourselves a little cylinder. 2 inches, and we'll extrude it to be 1 inch. So now we've gone a sketch on a plane, and from that we extruded to create a part. But then an assembly is where you would insert. So we've got that part, we've inserted that, but we can also go and insert on our other parts users. So for example, we haven't done a go build a part recently. Couplers, I don't even, and 6mm, generate, and there we've got a coupler. So those are parts that are put together in an assembly. Oh, forgot to show you something that we've done. We do have lots of kits in here. And this is an example of one go build a kit just to show you all of the mates that work. We will finish loading, and we are going to animate this one mate in here. Animate on the Y, reciprocating. And this is something that you get because all of the parts have the mates and relationships. And so this is one of the standard Go Build-A kits. They're 4-stage low cascading slide. As you can see, you can build nice animations with Onshape and all the parts. Other questions? When you create a part, send email to robotics@cghsnc.org. And if you can't remember that, if you go into the FTC Parts Library, there is a link in here, right here, that part status and tells you, just send email there.
And then it looks like there's some questions about actually getting access to the library. And so anyone who wants access can remember to email first@ptc.com. And please include the emails of everyone on your team that you'd like added to that part library. And then we can send that to everyone on your team that needs access to this library.
And they've been really very responsive at adding people to it. Okay. Other questions?
There's another question about mating parts. If you wouldn't mind showing again how you mated 2 of the parts.
Certainly.
And then I'd also like to remind people that there are the resources on the Learning Center too. So you can also go through a more longer form version of this where you can see how to actually go through some of the different mates and what those different types are.
And also, Tom Green, who's on the call here, does a Onshape learning session once a week I think we decided it's on Saturday. It's posted on the FTC Discord. If you want to attend, you can also send email to robotics@cghsnc.org and we'll send you the information for that. But let me show the mates. Go into this half robot here, and what we're going to do, when I was putting all of these parts together, and we were in a hurry, so we didn't. Let's show mates. There it is. Okay, I'm going to delete this mate here.
Yep, normally when we're not in a hurry, we'll name each mate so that we can look at the list and know exactly which one goes where.
Yeah, this would not pass muster. If one of the kids on our team actually gave us a model like this, they'd end up doing push-ups. So I want to mate this part. All right, I want this hole here to match up with that hole there on the pattern mount. So all I do, I click a fasten mate. We've got several different choices of mates, but I'm going to use a fasten mate. And I click, you'll notice what's really nice. I love this about Onshape. Whenever you highlight the surface, it gives you all the possible places you can mate to. So I'm going to mate it to the very center. And you see all those? I'm going to click on there. And this solve button is very much your friend. When you have what happens is, I put the mate, you notice it moved just one part. It only respected this one mate. Well, if you click solve, it shows me how it works with the entire robot. Now, you may have noticed earlier, it wasn't, when I first put it together, it didn't go into the right orientation. Well, that's where you can use this rotate. It'll rotate 90 degrees, and hit the solve, and you can see that it's the way you want it. Or sometimes you flipped it upside down, and obviously that's not going to work because the metal isn't going to go into there. But I can flip that, hit the solve. And the difference, by the way, there's two green buttons here, green check. This green check says, take the mate, I'm done. This one says, take it, and I want to do another one. And so there we go. Okay, other questions? Anything's fair game.
And there's another question about whether the slides themselves will be available for teams to review later.
Yes, yes, the slides will be available. Mackenzie, will you? I assume you have a way of hosting them, or should we just send out?
We can find a way to host them. Definitely, we can host them, and we can also include them, a link to them in the description on the YouTube recording, so that way you can find them with the YouTube recording as well.
Great. All right. Let's see. Can you share a link to the question? Can you share? I'm thinking we've answered this. The parts library link is basically in your Onshape. You have the parts library in the Onshape. If you go look at teams on the left-hand side, and it's going to be called, I mean, I have a lot of teams that I'm on, but it is the FTC robotics part users, and you will see the 6 folders underneath that. So go build a McMaster Rev Robotics, or 7, I can't count. And once you can see that, you can insert any of them into any of your models. And we do encourage, when you're using the parts library, to, when you do your search, only search against this so that you don't get this random thing from the Wild Wild West. We want your robot to look pretty. All right. Other questions? I'm having challenging with this questions panel. It only gives me one line at a time.
Another question was, what was the Discord channel again?
It's the FTC Discord. It's a global FTC Discord. We'll have to get you the link to it.
Put that in the description as well on YouTube video. Yeah.
I don't have it handy. Okay.
And if there's any other questions, again, people can be feeling free to put that into the questions panel.
Okay.
I think that's all we have for now.
Okay. We're hoping this has been useful. We've had a lot of fun. It's been interesting and challenging, and I will have to share that our experience with Onshape over the past couple of months has been really, really fun. Chris and I spent, was it 4 hours on Saturday, 5 hours, trying to figure out how to make the bevel gear.
Yeah, configurable bevel gear.
Yes, so we have yes, just to show you.
Yeah, I guess what we're trying to say is, like, we're really trying to put in the work to make it as easy to use as possible. We've been working on this library for about a year now.
So this is an example of a configurable bevel gear. And all the math is on the left-hand side. Chris is amazing at math. That's why he's a rocket scientist. And you can come in here and you can change the number of teeth from 32 to 24 to 16, and it completely redraws, regenerates all of the angles, all of the, pretty much all the shapes. You can also change the bore size for it, for whatever you want to put it in. But that's how far you can go with the library. And Onshape has got a huge amount of power to it, particularly with the configurations. I've played with a few other programs, and the configurations just seem to be done right.
Another question came in asking how many people can work on the project at a time.
We've had 9, 10 kids on our team all simultaneously working. There's no real limitation.
I was going to say, in fact, this is a thing that, if we're having practice and it's, in a design heavy phase, we'd really like to have, one of the coaches with their laptop up front and have it on the screen. And so basically anyone who's working on the assembly, you can double click their icon and follow what they're doing, if they have a question. Or for example, we've been doing all of our meetings over Zoom, but it's easy enough for not only for someone to share the screen, but also to just double click on their icon, see exactly what they're seeing, what they're clicking on when they're trying to edit stuff. So that's been very helpful.
So you can think about it, there's really 2 levels, actually 3 levels. There are 2 people that are actively working on assembling parts of the robot, and we've seen plenty of times where that's happening. There are people who are just working on an individual part. Someone's going off and modifying or building a side plate or something where they're working as part of the robot, but they're working in isolation. And then last, I'll call them lurkers. They're people that are watching everybody else. And this is a great opportunity for a new kid. So, a rookie team member to get used to Onshape. Sit there and just go follow somebody and watch what they're clicking on. And the beauty of it is you don't have to be sitting next to them looking over their shoulder, breathing over their shoulder. You can be, in the next room or, halfway across the city. It works very well.
The way I like to frame it is Onshape successfully made multiplayer CAD.
Yeah, actually, Chris and I were practicing building that robot together, and it took us a while to not keep moving the part the other one was working on. We've learned the tricks.
I do like that analogy of the multiplayer. There's another question that came in though. Are the motors present, or do we install their CAD files separately?
Are the motors present? All of the motors that we have found are in the library. So actually, if someone wants to give an example, let's just go look. Do we know what motor? Mars Orbiter. I don't know what the Mars Orbiter motor is. Do we have a?
Is that made by one of the 7 vendors? Yeah.
Mars Orbiter motor. Okay, that's not one from any of the vendors we have, but that's really easy to add. I like that idea of putting it in. So opportunity to go ahead and model it. Or if you need help, we can help you getting it modeled. But that's not from one of the 6 vendors.
The suggestion is an Andy Mark motor.
Is it an Andy Mark motor? Let's see.
No, they're saying, I think they're saying to do an Andy Mark one instead, since that's in the library.
So Andy Mark is the ones we've just started going through the list. So all the Neverrest motors are in there, and the gearboxes for the Neverrest motors. So the Neverrest ones, pretty much the standard ones that FTC students are using are in there. Also the Rev Hex motor is in there. We just started with the Rev Robotics on the FTC motion motors and servos. These, we've imported them, but we haven't got all the cartridges in place from the Rev stuff. So that's something that needs to be done to make that so that you can put it into a robot. But all of the Andy Mark, Servo City, the one thing that we do not have a lot of is servos. That turns out to be really, really hard to do. If we go to Servo City, servos, high tech, we have some of the servos, we have the common servos that are in there, but if people have servos that they particularly like or find a model for a servo, I've gone searching of the shall we say, 50 servos that Servo City carries, I can only find models for about a dozen of them. I've even emailed the vendors and asked them for models of their servos, and I did not get a positive response. Yes, and someone, the Ultra Planetary Gearbox and HD Hacks, that was the one I showed you there. All right, other questions? All right, well, Mackenzie, I will turn it over to you.
Great. I will show my screen again. So just a reminder, we do have some more webinars coming up. So next week, or actually this week on Thursday, we're going to be talking about collaboration and versioning. So I know we got a preview of some of that collaboration tonight, watching John and Chris work together. So we'll go some more into that and how you can be working and actually managing your versions as you're going through your design process. And then next week, we're going to have a team panel, again, where teams you can be asking some teams questions, talking about their best practices and what they've learned from using Onshape over the last few seasons. And then we'll be talking about preparing your submission for Robots to the Rescue. And then we'll have an office hour where you can actually ask us any remaining questions that you have before you submit. And then as a reminder, if you have any questions at any time, maybe if you go back and watch this webinar, the replay, or if you want to get added to that library, you can always be emailing us at first@ptc.com, and we're definitely happy to help in any way we can. So thank you again for joining us.
Mackenzie, I just shared with you the link. I got the link for the Discord if you want to share that with everyone. That's the First Tech Challenge Discord. Discord.gg/first-tech-challenge.
And I think we can share that with the audience. I just shared that with the audience so people can click that link if they're interested in taking a look at that. So again, thank you everyone who joined us tonight, and this will be recorded so you can share it with anyone that you'd like to. And thank you again, John and Chris. It was definitely very helpful. And we definitely all appreciate the work that you put into creating this library for other teams to use.
Thank you.
Yeah, thanks for Onshape.
And with that, have a good night, everyone.
Thanks, everybody. Have a good night.